those topics that you need to understand every single thing, every single detail. Otherwise, you will get confused. As soon as you have a question, ask right away. So recursion, main thing you need to understand is you need to have a base case and a recursive. Two things you have to have in a function. Call that a recursive function. So recursion is just a way of writing the code that would call the same function from itself. So that you can see here, it's calling itself from inside the function. So that's what is known as recursion. So you'll just loop through it. And to stop that loop, remember, you have to have a condition to stop the loop. In this case, it would be a base. So in this one, a base case would be this case right here. The reason this is the base case is because it's not calling recursion. It's not calling the function from within. So that would be considered base case. So that would just stop the recursion. Any other case, you would have the function calling itself this way and this one too, and then that would be recursion. The main thing you need to understand, you need to have, maybe this week, I'm not sure about how we do this today, but next week for sure, we're actually going to be writing these functions. So you need to figure out what your base case is and how are you going to write the recursive case. Cover the basics. So there are slides posted on Canvas. I don't like going through the slides here, reading the slides. I would highly recommend you going through the slides, and if you have a question, bring it on Thursday. We'll go over that, because I feel like going over the slides is just like a lazy way of teaching. I actually want to show you the code or write the code so you get a hands-on practice. I think I covered all the basics. All right, so let's get into recursion. So what is this method trying to do? So we got to figure out when call is mystery 7, so n is equals to 7. So we need to figure out what's going to be printed onto this. So when n is 7, so I'm actually going to do annotation and don't really know how that's going to work. So we have n equals to 7. So n equals to 7, n comes here, 7 comes here, and it goes into the first if 7 is less than 0. That's not true, so we don't go in there. And then we go else if 7 is less than 10. So we do go inside the else statement, and then we return this. So what would be printed to the screen, or what would be the return value when n is equal to? So that's a 2. So let's do the math. We have n plus 2, 7 plus, I'm sorry, n plus 1. So 7 plus 1 is 8, right? So we do the parentheses first, and then you have modulus 10. 8 mod 10 equals to what? 8. So the answer would be 8. Just return 8. So you just come in here, and write 8. So we actually haven't got into recursive case yet. This was just the base case. So we got 7, and we just calculated just any regular function would do, and we returned. Oh, so we're still here. Yeah. So now next is n is equals to 42. So n is equals to 42. 42 comes in here. Is this true? So how did you reach 8 when it has mod 10? All right. So the previous one, let's go to the previous one. We had 7 here, right? So 7 plus 1 is 8. 8 modulus 10. That would be, have you guys covered modulus in the previous class? How modulus works? Okay, yeah. So modulus is just, you take the remainder. So you do 8 divided by 10. So this is 8 modulus 10. And this is what happens. So you have 8 divided by 10. So how many times 10 goes into 8? So 10 goes into 8 0 times, right? Because 8 is less than 10. So you do 10 times 0. It is 0. And you take the remainder. In this case, I'm just writing with my mouse, so I'm saying a lot of mistakes. All right, so the remainder would be what is left over. So in this case, the leftover is 8. So now we have n equals to 42. So I got an answer. I think Jennifer said we don't go in there because it's not less than 0. Do we go in this one? 42 less than 10. 42 less than 10? Nope, we don't go inside that statement either. So the only thing left is the else part. So now we go in here and we try to solve this. So we have 10 times, so we have, when n is equals to 42, we have 10 times mystery, 42 divided by 10, right? And then we have n, which is 42, plus 1 mod 10. So we need to solve this. So we have one unknown, right? So we have this right here is unknown. We don't know what that is. So we're going to call recursion on it. And we're going to pass that, call the same function again. So now the new value of n would be, what's the new value of n when this function is called? N equals to 4. So 42 divided by 10 is 4 because we take integer division. So we don't take 4.2, it's just 4. If it was double, it'd be 4.2, but it's an integer, we take integer division, which is just 4. So now we do this, call this function. So we have this function again with the new value of 4. We go through each step. Is this true? No, that's not true. Then is this true? Yes. So we 4 is less than 10. So we go in here and we return this. So the value would be returned would be 4 plus 1, which is 5. 5 mod 10. What value would be returned? So 5 would be returned. So return 5 at this level. That 5 will go back and gets plugged in right here. So this whole thing will become 5. So now we backtrack everything. So we had the unknown. We found what the value was. We plugged that 5 back in, and then we can solve this equation. So now we have 10 times 5. Oh, well, what would we do first out of this? So now the mystery and all this is gone. We solved what that is. That equals to 5. 5 gets plugged in here. Order of operations tells you what should you do first. Parentheses first, we have 42 plus 1, which is 43, right? 43, and then you have 10 times 5 plus 43 mod 10. So now what's next? Multiplication. So you do left to right. So multiplication and mod and division, they're on the same level. So if that's the case, you do from left to right. So you do 10 times 5, which is 50. Then you have plus 43 mod 10. 43 mod 10 is, what is 43 mod 10? 3. That would give you 3. 50 plus 3 equals 2, 53. So the function would actually return 53. So let's move on to the next one. So I'm going to delete all of that. So next we have n equals to 385. N equals to 385. So we have a big number. So I think in this case, we'll have multiple recursions. So n equals to 385. This is not less than 0. We won't go in there. 385 is not less than 10. So we won't go in there. Then only thing left is the else part. We go inside here. And this is the recursive case. And in this recursive case, we do, so n is equal to 385. And what happens there? We have this equation that we need to solve. We have 10 times, because I'm going to run out of space. 10 times the mystery, 385 divided by 10 plus 385 plus 1 mod. So n is 385, and this is called. Now we have known, we need to solve it. And what's the value of n that is passed in for the mystery, for recursive case? 38. So n is equals to 38 at this level. So there are levels to recursive case. So you just got to keep track of the value of either n or x or all the parameters that are passed in. And the only way you'll be able to keep track of it if you just write every single thing down. Is 38 less than 10? No, that's not true. If we move on, we go into the recursive case again, and then we have the same equation again. So at this level, we're going to have 10 times mystery 38 divided by 10 plus 38 plus 1 mod. So now we have an unknown again. So we're going to call recursive again. And what would be the value of n at this level? 3. N equals to 3. And when n equals to 3, we're calling this function again. Is this true? That the first one is not true? Yes. So with 3 is less than 10. Remember, the base case stops the recursion, right? In this case, when the value gets less than 10, that's when the recursive case is stopped, and we just return this. So we just plug in 3 right there. 3 plus 1, which is 4. 4 mod 10 is, what's 4 mod 10? 4. So we return 4. 4 comes in here, gets plugged in right there. Then we backtrack everything, going back to the first level, right? So 4 gets plugged in here. 4 gets right there. Now we don't have mystery call anymore. We have number 4. We know the value of that. Now we have 10 times 4, which is 40. So this will equal 40. And then we have 38 plus 39 mod 10. So 39. So what is 39 mod 10? 9. So 39 mod 10 is 9, and the value would be 49. Make sense? So if I make a mistake or anything, let me know. We can go back and backtrack and see where we made the mistake. Now, this right here, recursive call, we know the value of that. The value of that is 49. So 49 gets plugged in here, and we can cross off the mystery call because we know the value of that now. So now we have 10 times 49, which is 490. And then we have 385 plus 1, which is 386. 386 mod 10. What's the value? 6. 386 mod 10 is the 6. So the answer would be 449. So now 496. We don't have anything to backtrack. That was the first level. So the answer would be 490. Sorry about my handwriting. I feel like I should just use the text the whole time. All right. So now, if you can see, this is the actual in-class assignment, but there we have 3 questions on there. I'm going to 790 and see what we actually get. So the n equals to negative 790. When it's negative 790, it is less than 0. Is this the case? We have this would actually return negative mystery function again with positive value, right? Calling the recursion with the positive value, and then we don't know what this is going to be. So we call recursion again with the value of 790. So it's supposed to be an arrow. All right, so now we have 790. 790 comes in here. It is not less than 0. It is not less than 10. So we go in the recursive case. This is the recursive case. This is also a recursive case, but it's a special recursive case. So you can have multiple recursive case and you can have multiple base cases, but you have to have at least one of each to be considered recursion. All right, so now it's 790. 790 comes in here and we execute this statement. So now we have 10 times mystery 790 divided by 10 and plus 790 plus 1 mod 10, something like this. So now we have an unknown, which is this right here, the mystery part, and we need to figure that out. So this is the recursion. What is the value of n at this level? 79. So we call recursion with n equals to 79. 79 comes in here. That's not true. 79 comes in here. It's not less than 10. We go into the recursive case again, and then we have the same equation again. We have 10 times mystery 79 divided by 10 plus 79 plus 1 mod 10. So now we have a recursive case again. We're going to call recursion, and this would be the unsolved mystery. What is the value of n when we call recursion? It is 7, because remember, we don't take 7.9. It's integer division. We call recursion on 7. 7 comes in here. It's not less than 0. We don't go in there. It is less than 10. So we go into this base. So now 7 get plugged in right there. 7 plus 1 is 8. 8 mod 10 is turn the value of 8. 8 gets plugged in here. Now we backtrack all the way to the top. So 8 gets plugged in there. Don't have mystery anymore. We have 10 times 8 is, so this equals 2. 10 times 8 is 80, plus 79 plus 1 is 80. 80 mod 10 is, so this would equals to 8. So now 80 would get plugged in right there, one level above, which is right here, 80. And we cross this off. And now we need to solve whatever this is going to be equals to. This is going to equals to 10 times 80 is 800 plus 791. 790 plus 1 is 791. And 791 mod 10 equals to 1. So that would equals to 8. So this would be 801. We don't have mystery anymore, but we do have that negative sign, right? So that negative sign would just carry over. So the answer would be 80. Answer is 801. I'm not going to do the last one. It's the same concept. So if you were able to find your mistake in here, you'll be able to the last one. Let's move on to the next one. I'll go ahead and get you guys started on the next one, and then you can finish it off in the breakout. So I'm going to clear everything, close and restart it out. So the next one is still a mystery, but we have 2 parameters, and they're actually print statement inside of it. So which one is the recursive case? So it says 1, 2. So which is the recursive? The third one is the recursive case because that's the only one that's calling itself. The other 2 are the base case. 1 and 2 are the base case. That's your stops the recursion, and we just backtrack after that. So let's do 2 together, and then you can go into your breakout rooms. And then the first one is to keep track of all the values. So we have x equals to 3 and y equals to, right? So now we go with these values. Is this true? 3 greater than 3. So we don't go in there. The second one is 3 equals to 3. So we print this out and we're going to print equals 3. The answer for the first one would be equals 3. And we don't do anything else because it's not called a recursion. We just print that out and all that. So now then we go to the next one, and the next one is equals to 5, y equals to 1, right? So now we go in and is x greater than y. So we just print out a star. This one is, we're not doing anything else. We just get out of it, and that's 2, 1 with the recursion. So the next one is 1 and 5. X is 1, y is 5. So now we go in there, is x greater than y, and are they equal? They're obviously not equal. And then we go into the recursive case. So now what happens is we print this out. So we print y, the value y, which is 5. So I'm going to keep track of the output on the right side. I'm going to keep track of the output right here. So it's going to be 5, and then we have a space. Print 5 and a space, and then we call recursion. So when we call recursion, which is calling the same method again, we don't execute anything afterwards. So we just do stop right there and wait for this command to execute. So we call recursion. So the next value when we call recursion is +1. So x equals 2. What's the value of x? And y equals 2. So now we go back and execute everything. Is this true? Is x greater than y? They're not equal. So we go into recursive case again. And then when we get into recursive case, we execute the first print statement as we see it. So then we have value y, which is 4. So it's a print statement. It's not print ln. So we're going to be printing on the same line. So we have 5 space 4, and then we call recursion. Remember, we still have this to execute. We're not going to execute it afterwards. I mean, we're not going to execute it right now. We're going to come back to it. We need to solve what the mystery is. So in this case, we have, when we call recursion again, we have x plus 2. X was 2, so x would be equals to 3. And then y would equals 2. Y minus 1 would be 4 minus 1 would be 3. We go back and we check all the conditions. X is not greater than y. We don't go in the number 1. For the second one, we have x equals y. In this case, x equals to y, 3 equals to 3, and then we print this statement right here. So we print equals the value of y, which is 3, and then equals. So now this is the base case. This stopped recursion. Now we need to go back to the function that it was called from, which is just right here. And then we're going to execute all the lines afterwards. So we go to this level and we execute the next line after that. That would be this one. And that would be the printing the value of x, which is 2 at that level. Remember, we don't print 3 because that level is gone. It was at this level. We're backtracking now at this level. It was 2. That's what we print. Then we backtrack one more time and we print this line again at this level. The value of x was, so the answer for the third one would be. And if there were any more recursion to backtrack, we'll just keep going. But then remember, this was the first one that we started from, so we just stopped right there.